Good morning. I am Jason DeTiberis, and I am the track host for the performance track this morning. Please make sure that you go back to sketch.com and rate this talk at the end of it. Our speaker today is the lead of the Platform as a Service team at Box, and he's going to tell us about how they implemented an SLA for the platform. Please welcome Shrenik Dedhia.
Hey guys. So my name is Shrenik. I've been at Box for about 2 years and a couple of months now, and before Box, I used to be at Apple. I'd like to talk to you guys about why we thought of and how we implemented an SLA for our platform. Things I'd like to go over today are what does Kubernetes look like at Box? What's the problem that we had? What are solutions we looked at? What are the principles we used to kind of navigate our way? And finally, what kind of solution we picked? This slide will give you a quick, brief history of time of Kubernetes at Box. As you guys know, Kubernetes was GA'd, I think originally like mid kind of 2015. We picked it up right away, and we implemented our platform on top of it. And we actually GA'd our platform internally around like mid of 2016. We called our platform Skynet, which is a reference to Terminator. We wanted our platform to become self-aware at some point. And through the years, we've kind of scaled ourselves to kind of where we are today. We run about 150 plus services in production today, which is roughly 75% of Box's kind of the stateless footprint. We run about 2,500 pods hosts with 1,000 in the largest cluster. This amounts to roughly 25% of Box's compute kind of the data center footprint. We have about 9 production-grade clusters across 3 regions. They're all in actual bare metals. We have about 25,000 pods across all of these clusters, with 9,000 pods in our largest cluster. We built a platform as a service on top of our Kubernetes infrastructure with the mission that we wanted to allow other Box teams to run and manage their applications in a secure, efficient, reliable manner in any region of the world. Our platform has minimal abstractions on top of Kubernetes. So as Box teams kind of onboard onto our platform, they have a bit of a learning curve to learn about kind of Kubernetes APIs and stuff when they onboard. We use GitOps. We have a declarative config that sits in Git. We use JSONet to express that configuration and to also compile that into kube manifests that ultimately get applied to our clusters with the kube applier. Kube applier was a project that we built at Box, and we've actually donated to the open source. Other things we have in our platform are cross-cutting concerns. For example, we have an internal CA that delivers PKI to the pods. We use HashiCorp Vault to deliver secrets. We use Calico for network management and for IPAM. We use SmartStack for service discovery. We're actually at a point where we're pushing the scale limits for SmartStack, and we're looking into replacing it. We use Artifactory for image management of our Docker images, Jenkins for pipelines, and finally, we use namespaces and RBAC policies to give granular access and control on a per service basis. Back in 2017 or 2018 timeframe, we actually went through a bunch of problems and scalability challenges in our platform. And as we were implementing fixes for our platform for those stability problems, we had we had two kind of thoughts. We didn't know how much the improvements were being made by those fixes, and we didn't know how to prioritize those fixes because we didn't know what the bar we were trying to hit at. And so we were kind of in this mode of, hey, how do we measure our platform health? And we were kind of, there was this conundrum of questions that we came across. What is our service level agreement? What is our key performance indicator? Do we even support things like saturation, throughput, traffic, et cetera? What is the service level objective? Is it 3 nines, 2.5 nines, 4 nines? How do we measure these service level indicators? Further on, what's the breadth of this problem? Do we measure our control plane? Do we measure our data plane? Both or something else? Do we go? What's the kind of depth we measure at? Do we measure at a cluster level, at the zone level, or at a region level, or across the board? We also looked at what the industry kind of thinks about this problem. Here's 2 instances of what we found from these are statements from the SLAs of some cloud providers. And the thing that I want to point out here is these are liberal kind of assumptions. What this really boils down to is that if your service has at least 1 instance that is alive and actually taking traffic, then your service will not be considered unavailable. And that's pretty liberal. Like if we were to implement the same principles in our platform, we would be, we would basically set up ourselves for like kind of like failure. So we started simple and we began exploring some solutions. The first solution we kind of thought of was, hey, let's just go ahead and count the number of minutes that we've degraded our box.com site at. This was very coarse, and it did not account for a large number of other problems that were happening within our platform. Basically, not all PaaS degradations would cause box.com degradations. So we went one step ahead. We began measuring the percentage of 500s from the API server, and we call this our control plane availability and uptime. There were some problems with this as well. It did not account for other types of errors that happen or actually showed up in the API server logs, like 400s. It did not account for like scheduler issues. It did not account for controller manager issues. In effect, it did not account for the data plane. And so we went ahead and implemented a synthetic test to represent our data plane availability. This synthetic test would run every 10, 15 seconds, and it would run on a subset of hosts, and it would test a subset of the kind of features for the life cycle of the pod to kind of see when can a pod be created, is a pod receiving the assets that it needs, for example, PKI, and secrets, et cetera. Then again, this wasn't real. It wasn't representative of our customers. It was like synthetic. And so at this point, we kind of stepped back and kind of asked ourselves, what are the questions we want to really focus on from all of the conundrum? And 2 questions really stood out. One was, what do our customers really care about, right? And the second question was, how do we leverage Kubernetes itself to build an SLA for our platform? Customers normally care about more about the ease of use of the platform itself. They care about keeping their own service up and running at all times. And they care about how to serve 100% of the peak traffic at all times. They don't necessarily care about the control plane availability. If our control plane dies, they don't care. They shouldn't even come to know. A lot of our customers have begun telling us that they actually don't care about the Kubernetes API itself. Remember, I told you that our platform has very few abstractions, and that customers have a learning curve to understand Kubernetes. People started telling us that they actually don't want to learn about Kubernetes like a whole lot. That's a separate problem, but I just wanted to kind of highlight it here. And finally, customers care much less how the platform implements protections for it from things like hardware failures, software failures, ensuring there's enough capacity available for like bin packing your pods in or maintenance, etc. We also looked at a bunch of protections that Kubernetes offers. Liveness readiness probes, which all of you guys know about, hopefully. Rolling updates is a mechanism that helps block the propagation of bad changes. PDBs, more recent concept. It protects the service from administrative disruptions. And there's another kind of, it isn't a feature, but it's a method of how you configure quality, the quality of service for your pod by specifying the resource requests and limits of your containers. And it's, you can set your pods to guaranteed, burstable or best effort. We choose guaranteed. Principle behind that, and actually guaranteed means to set your pod requests at the same level as your pod limits, container requests and limits. So you don't give more CPU to your limits than your requests. The principle behind this is when we looked at our traffic or peak traffic, we noticed that all of our services were actually peak during peak traffic. And if all services would attempt to burst and use more CPU, we would cause a lot of noisy neighbor problem. So our recommendation to our service owners was use guaranteed mode, and if you want to scale for peak traffic, then actually scale horizontally. Create more replicas and not increase the CPU like memory on each of your containers. And there might have been other kind of knobs which we didn't explore at the time. We realized this was almost a year and a half ago that we kind of explored this. And we're actually running a version of Kubernetes that's far behind the upstream, so we're kind of limited in the features that we can use. So the solution that we landed upon was a CRA, critical replica availability. Principally, we wanted to build a platform that provided high availability services. We kept in mind two things, kind of high level. If the platform doesn't meet the HA needs of a service, then somehow that should show up in the platform's health metric. Conversely, if a handful of services can't get HA, then something is probably wrong with those handful of services with themselves. This isn't the problem at mass. And so we went in the hat of implementing something that provided accountability to all of our service owners and enables us to prioritize the fixes that we were making against our kind of stability problems. Conceptually, our customers, our tenants, our service owners would define a minimum healthy number of critical replicas that would be needed for the service to be able to serve 100% of traffic at peak. I've left out details about how this is actually configured on a per cluster or a per data center or a per zone region level, just keeping it simple for now. Once we got that from our service owners, we would go ahead and our platform would both calculate and automatically configure Kubernetes protections for those services. Taking an example of that, realize that the values that I'm going to go through here are very suggestive. The method is also very suggestive. This might not be exactly what we do because we're constantly changing and evolving. But I wanted to show this to actually serve as a basis for how you would think about building your own SLA. So a customer, which is our service owner, will actually define their critical replica threshold, let's say 100 replicas. They would go ahead and configure their liveness and readiness probes to ensure that they account for their own dependencies. And also, they would use the guaranteed quality of service. They would ensure that the request limits match their request match limits on the resources. And then the platform would come in and begin adding protections on top of that in a layered fashion. Bottommost layer would be hardware protection. A service should be able to lose X number of pods if there is a hardware failure. Assuming 5% hardware failure, 5% of the pods of the service can go down at any point of time. So we need to run 105 pods. On top of that, we added the pod disruption budget buffer, which was to allow administrative disruptions. Hey, I want to go ahead and I'll drain a couple of hosts because there's a problem and I need to bounce them. On top of that, we added some sort of a rolling update buffer. Hey, at any time there's a hardware failure and there's a disruption going on, and there's an administrative disruption going on, I still should be able to do rolling updates. So added that buffer here. And then finally, another buffer for maintenance. For example, if I want to be able to lose a whole rack for like maintenance. And there could be many more levels. We haven't completed our full story yet. But what I want to tell you here is that even though the service actually needs 100 replicas to be available, we actually gave the service 117 pods. And we actually gave the service 123 pods worth of capacity. Right? How do we measure the SLI? How do we really measure this? So we take the minimum replicas required for HA for every service. And then we calculate the available replicas for every service over comparing the total available with the CRT. In our example, the total available was 117, and the CRT was 100. And then we calculate the replica availability, which is a percentage of the CRT. So as long as that service had more than 100 pods alive at any given time, between 100 and 117, we would consider that service to be 100% available. And the moment that service would actually start losing pods below 100, we would start accounting for that in our CSA. And finally, we would take an aggregate, would take a simple average across the availability for all the services across a given arbitrary period of time. Here's an example of what the metric looks like for us today. That's for the month of October. And as you can see, we are well above our SLO. Why we chose 3 nines of SLO and the story around that is probably a topic for some other time, but I can stick around after the talk if people want to know. So even though we built this, the project isn't complete. We are aware of a few gaps that I want to talk about, and there's a bunch of future work that we want to do to improve this. We realized that massive system failures are things we cannot do anything about. They will impact our SLI regardless of what we would have actually chosen to measure. Next, an interesting thing about the way we calculate our CRA is that we treat all services equally. Some people might think this is a feature. We should treat everybody equal because this is a platform. And other people might think this is a bug. We should have some more tiering. We think it's a bug because we do feel that we have a class of services that are more or less in the critical path of customer traffic. And so there is an actual reason to create tiers of services. So that's something we would want to fix in the future. Maybe we do that using weight averages. I don't know. We haven't explored that yet. We also realize that we're subject to service owner-induced errors. For example, if a service introduces a bad change, which has a latent bug that shows up after a couple of days and crash loops a bunch of their pods, there's no way we could have protected against that, and that would ultimately show us the CRA actually going down. Or, for example, a service which hasn't really configured its liveness probes correctly for us to get into a state where our CRA shows good, but the platform actually has problems underneath. Some future work that we want to do, we would like to leverage new features of Kubernetes. For example, pod priority and preemption. Realize our central point of CRA is that we want the platform to at least maintain the critical number of replicas at all times. So let's say we have a situation where we lose 25% of our capacity, and we have 100 services, from which 99 services are healthy. They have all of their critical replicas up and alive, but there's one service which has lost half of its pods. We don't have a mechanism that will go and kill the healthy pods from all the 99 services so that we can make room for the critical replicas of this one service which is unhealthy. And so we need a feature from Kubernetes where we can express the fact that we want to keep the critical replicas of these services alive at all times, even if it means going and killing healthy pods from other services. We want to improve our tooling around HA. For example, we want to improve the way we do canarying. We want to introduce more chaos in our system. When we built our platform, a large number of tenants actually moved over from the bare metal world over into the Kubernetes platform. And they kind of brought along with them some anti-patterns and some bad architectures. When you're in bare metal, you're not necessarily thinking about if my machine dies at any point of time, how do I recover? How do I converge across my kind of healthy instances and so forth? Well, deployments are really controlled and tightly orchestrated. So a lot of the services that we are running today aren't actually completely built for hard shutdowns. And so we want to, and really, if hard shutdowns happen, those services take a long time to kind of recover and become healthy again. And so we want to introduce more chaos so that we can help those services improve their architecture in order to ultimately improve our CRA. And lastly, we want to have a kind of a stronger service owner accountability. We want to implement some system where all services on our platform get out of box alerts, so that if their pods start dying, they get paged, and they need to come back and fix those. Or implementing some sort of a policy where if we find that a service is misbehaving or they haven't responded to their page in a while, we exclude them from our SLI, and they actually don't get our protections anymore. That's it. That's all I had for tonight. I'm happy to take any questions if anybody has.
How do you deal with like SOC compliance, SOC 2 compliance, where developers can't access prod? Or do you have that issue?
Developers can't access prod?
Yeah.
We use, our developers actually can access prod, but they can access prod through specific controls. We have jump machines, bastions, which have appropriate ACLs kind of applied to them that enable them to access prod, and then that's the infrastructure level access. And then on top of that, we have Kubernetes RBAC, and we use LDAP for authentication as well. So a developer can only access their own services in production. Does that answer your question? I see.
Like they're not even allowed to view the pods,
I see.
Yeah.
I have some other members from my team here, here in the room. Maybe we can hang out outside because they have more information about some of the things you're talking about.
Sure.
Can you tell us more about your tooling that you use to add additional pods above the customer-defined CRA?
Sure. One of the slides mentioned we have a declarative configuration system that we operate in Git, and we use JSON to express that configuration. We've built a closure in we use JSON to actually compile that configuration and produce Kubernetes manifests. We've built a closure in there which actually manipulates Kubernetes manifests before they are written back into Git. And that's how we expect the users or the service owners to express their critical replicas. We read that in our closure, and we emit new protections, for example, PDBs or rolling updates, and we bump up the replicas to what we think is actually best for them, and then we actually write it to Git. Yes, back to the same repo, exactly. So both the intent and the full manifest actually goes in the same repository. So if service owner makes a change, compiles it locally, that produces a set of changes in the release folder, and that gets committed as one block.
Yeah, if there are other elements to the platform that a team provides, say EFK logging support or service mesh that's also considered part of the platform, any suggestions on extending this to those other services?
That's a great point. So two answers kind of there. One is not all of our systems that we have today are built for Kube native. One of the fundamental reasons we can do this is because we are heavily using the Kubernetes controls. So if you have a system which has all of these integrations, which are also kind of like Knative, maybe then it'll be much easier to kind of find out if there are controls which we can use to automatically protect services from doing the right thing. The other way to look at this is that because we have a declarative system, we can actually go ahead and build those things out even for those integrations, even if they aren't Knative. We haven't really thought about this problem, but we think we have the right set of tools to be able to address at least a small portion of this.
Hi, great talk. So on one of the slides, you said customers care about ease of use, the availability of their service, and serving 100% of the traffic. But it looks like with CRA, you're only tackling about the second part, which is availability.
Which is last two, actually.
The last two. But how about other parts of the platform? Like, what if your ingress is down? Then
that's a great point. I'm going to answer that in two ways. One is we encourage services to build as much health as possible into its liveness and readiness probes. And part of solving that is if the egress is down for the service, then build it in a way that actually trips the liveness probe or the readiness probe, so that actually shows up in the health of the service. The second answer to your problem is that this is not a silver bullet. You rightly pointed out, this is not the only metric that we want to track and think about. There are lots of other metrics that we use. For example, how fast can a change make it into production? How many changes can be made in parallel? How much time does a developer spend on actually babysitting their pipeline? But when we thought about this, we wanted to think about one single metric that we can project both upwards to our business and project downwards to our customers that can bring us all on the same page. But this is certainly not the only thing we track.
Yeah, great talk. So is it tricky at all for teams to define their critical pod level or pod count? Like, do you find some teams don't know or have to iterate for a while?
Yes. If I kind of understood you correctly, what kind of guidance do we provide them on setting the right critical replica? We address that in a couple of ways. One, we kind of admit that we don't have the right tools in place for a service owner to go and actually do performance testing of their application to actually see how many pods they need to be able to serve peak traffic. On the other hand, we do have a separate capacity engineering team which actually monitors both the capacity and the utilization of the service to get a sense of where the service is at in terms of its headroom. And that's one way we kind of use to kind of assess what's the right range there for the replicas. Part two of your answer is that we actually ran this program as an opt-in program. We didn't force everyone to implement this right away. We implemented the controls for that, for this, and we expressed a label that one could apply to their deployment. If we found the label, it would be treated as an opt-in, and we would actually start emitting those protections. And if a service didn't have the label, we actually would emit warnings during our build that, hey, you should start opting into this program and figure out the replicas you need. Yeah, can I answer your question?
Yeah, thank you.
Just a follow-up to that, what kind of guidance do you provide to your customers about what their health checks should be doing to define readiness? And what's your feedback you've gotten from your teams about this particular metric?
Yeah. Most of our, so I think there were two questions there. To answer your first question, how do we provide guidance to what the right thing to do is there? We actually have an internal wiki where we produce all of our guidelines and guidances and all that. We actually have a full page about how should you configure your liveness and readiness probes with examples of situations that you should treat and you kind of shouldn't treat. I don't remember a lot of things from the top of my head, But we do have things, for example, like I think in the readiness probe, don't actually check or don't make outbound connections or network connections in your readiness probe. Do something with in-memory checks that you can quickly respond back. We have a full set, and we point all of our service owners to that page, and we constantly kind of improve it. We also have a lot of links in there that point to upstream best practice and kind of sources. That's the way we kind of actually mitigate that. We don't have a formal way of actually going into all of our services and actually verifying whether they're actually using it the right way. What do our customers actually think about this? It's an interesting question. I think it partly answers someone else's question. We haven't fully completed this program yet. We think about, I don't know, maybe 10 to 20% of our customers have actually opted into this. So we haven't reached that critical mass where we, where we have that kind of feedback from them yet. We hope to finish this program by the end of next year. We're an enterprise company. Everybody has lots of priorities, and so we can't have everyone fix this and opt in like within a short period of time. But hopefully at some point of next year, we'll have much better answers.
All right, I know some of you still have questions, but we have reached time, so if you could try to take those conversations out into the hallway. And please do remember to rate the session on Sketch.com as well. Thank you very much. Thank you.